Hello everyone. Let's discuss about preparation and properties of potassium permanganate KMnO4. Permanganate ion is MnO4 minus. Its oxidation state is 7 and group number is also 7. So if a question is asked like give an example of a oxoanion in which the oxidation state and group number are same, then we can also write permanganate. It is dark purple in color, almost blackish. Solubility in water is quite low. It has low solubility in water. It is isostructural with potassium chlorate KClO4, and the two have tetrahedral structure. Both of them show tetrahedron. Used in textile industry, to bleach fiber. It is used for decolorization of oil and also as a powerful oxidizing agent. Oxidizing action of permanganate ion that simply depends on the hydrogen ion concentration. If there is a change of one electron, then permanganate changes to a manganate ion. If there is a change of 3 electron transaction is there, then this permanganate ion it changes to MnO2. And in case of change of 5 electron, it changes into a Mn2 plus. More the transaction of electron, powerful the oxidizing action. So that's why potassium permanganate it act as a powerful oxidizing agent in acidic medium, because in case of 8H plus strong acidic condition is there and there is a transaction of 5 electron, and if the hydrogen ion concentration is approximately 1, in that case reaction is kinetically slow. Rate of reaction is slow in that case. Two oxoanions of manganese are permanganate MnO4 minus and manganate MnO4 2 minus. In case of permanganate ion, oxidation state of manganese is 7, which is same as the group number. Group number and oxidation state in case of permanganate ion, that one is same. Manganese, that one is surrounded by 4 oxygen here. So the resulting structure is tetrahedral. And in this tetrahedral structure, there is a Mn double bond O. Manganese is a metal having vacant d orbital, and oxygen that belongs to p block, it has p orbital. So this pi bond is formed here because of the p orbital of oxygen and d orbital of manganese. So the resulting overlap is known as p pi d pi overlap. This pi bond is formed because of a p pi d pi overlap here. In case of manganate ion, oxidation state of manganese here is 6. The resulting structure, that one is Mn, is surrounded by 4 oxygen. So the resulting structure here is tetrahedral, and MnO bond that arises because of p pi d pi overlap between manganese and oxygen. Variable oxidation state during a reaction, course of a reaction. Let's start with manganese, Mn. It is 3d5 4s2. Its atomic number is 25. This manganese during the reaction, it changes to Mn2 plus. Its configuration is 3d5. It is half filled. As it has 5 unpaired electrons, so it is paramagnetic, and it doesn't have any specific color. This manganese, it changes to Mn4 plus. Mn4 plus means MnO2. So in MnO2, its configuration, it becomes 3d3. It has 3 unpaired electrons. So again, it is paramagnetic, and it is blackish in color. Then this MnO2, it further changes to Mn6 plus. Mn6 plus means MnO4 2 minus magnate ion. MnO4 2 minus we have. This magnate ion, its configuration is 3d1. It has 1 unpaired electron, so it is paramagnetic and dark green in color. Magnate further changes to Mn7 plus, which is permanganate ion. Permanganate ion 3d0, diamagnetic, and its color is dark purple. Preparation of potassium permanganate from its ore, pyrolusite, which is MnO2, and its color is blackish. So MnO2, when fused with alkali in presence of air, it changes to potassium magnate, and byproduct here is water. 2 moles of MnO2 react with 4 moles of KOH, changes to 2 moles of K2MnO4 and 2 moles of water. The resulting magnate ion in acidic medium, MnO4, magnate ion in acidic medium, on acidification, it changes into permanganate and produces byproduct MnO2 and H2. So in this case, 3 mole of magnate ion on acidification with 5 moles of H plus changes to 2 moles of permanganate and 2 moles of water here. Commercially, MnO4 2 minus magnate changes into permanganate on electrolytic oxidation in alkaline medium. And in a lab, Mn2 plus changes into MnO4 minus in the presence of S2O8 2 minus, which is, this one is known as peroxo disulfate. If we simply check a reaction of magnate ion which on acidification changes into permanganate and MnO2 plus H2O. In this case, if we simply check magnate ion, manganese is in 6, permanganate it is in 7, and in MnO2 it is in 4. So 6 to 7 increase of oxidation number, 6 to 4 decrease of oxidation number. It means in this case Mn, it changes from 6 to 7 and 6 to 4. So such reaction, that one is known as disproportionation reaction. Same element get oxidized as well as reduced. So the second step, which is the acidification of magnate ion, that one is a disproportionation reaction. Now let's discuss about reaction of potassium permanganate in acidic medium. As potassium permanganate, that one is a powerful oxidizing agent in acidic medium. It changes to a Mn2 plus. There is a transaction of 5 electron here. Reducing agent. In this case, suppose you start with the oxalate. So oxalate, it changes to carbon dioxide in presence of potassium permanganate. If we are having ferrous, ferrous changes to ferric. What you do, simply increase the oxidation number here. If we are having nitrite, nitrite changes to nitrate. Iodide, which we get from Ki. Iodide changes to iodine. Sulfite, which we get from sulfurous acid, H2SO3. It changes to sulfate, sulfuric acid. In case of neutral or weakly alkaline medium, MnO4, it changes into MnO2. So in this case, S2O3 2 minus, that one is changes to SO4 2 minus. Mn2 plus changes to MnO2. Iodide changes into IO3 minus. Yes, an important point here. Iodide. If we take an acidic medium, then it produces iodine. And if we are taking water or weakly alkaline medium, then this iodide ion changes to iodate. Let's frame word problem based on preparation and properties of potassium permanganate. A 3-marker question. A blackish brown compound A, a blackish brown compound A on fusion with alkali and air changes to B, which is dark green in color. This B on electrolytic oxidation in alkaline medium changes to C, which is dark purple in color. Identify A, B, and C. So a blackish brown compound, this one is MnO2, dark green K2MnO4, and a dark purple is a KMnO4. Let's practice one more word problem. with alkali and in presence of air changes to a dark green compound A. This dark green compound on acidification with dilute sulfuric acid changes to a purple compound B. This purple compound B with Ki in acidic medium produces violet vapors or violet coloration of a compound C. This B on reaction with Ki in weakly alkaline medium produces a compound D which is KiO3 here. Identify produces a compound D. So A is K2MnO4 dark green. Purplish compound of manganese is KMnO4 potassium permanganate. Potassium permanganate in acidic medium violet vapors, that one is iodine, and in weakly alkaline medium it produces KiO3 potassium iodate. Let's discuss one more word problem. A black compound of manganese in alkali and presence of air changes to a dark green compound B. This compound B on acidification changes to a purple compound C. Purple compound C with ferrous sulfate in acidic medium, it gets decolorized to produce a compound D. Color of compound C disappears on treatment with acidified ferrous sulfate. So identify A, B, C and D. So black compound of manganese is MnO2, dark green is K2MnO4, purplish is KMnO4, and this KMnO4 with ferrous, it color gets disappeared, so it changes to Mn2 plus. MnSO4 will be formed here and the ferrous changes into ferric. Another category of question that one is asked from preparation and properties of potassium permanganate, that is a fill-up type of, like MnO2 plus KOH plus O2. Next we take MnO4 minus with oxalate ion and H plus, MnO4 with hydrogen sulfide. Hydrogen sulfide produces sulfide ion here. In acidic medium, MnO4 minus with thiosulfate. In weakly alkaline or neutral medium, MnO4 minus plus iodide. In weakly alkaline or neutral medium, MnO4 minus plus 4H plus 3 electron changes into, and finally, most importantly, decomposition of potassium permanganate. So in this case, first reaction, let's start with the first reaction here. In case of first reaction, we are having MnO2 with KOH and O2. So this one reaction is what? Preparation of potassium permanganate. So the answer here will be KMnO4. In second, that one is a redox reaction. As a medium is acidic, so permanganate it changes to Mn2 plus, and oxalate it changes to CO2 in this case. In the next reaction, we are having permanganate ion with a sulfide and in acidic medium. So in this case, MnO4 minus, it changes into, as the medium is acidic, so it changes into Mn2 plus, and sulfide, it changes into a colloidal sulfur which is yellow in color. Next we are having permanganate with thiosulfate and water. So MnO2 and SO4 2 minus. In this case we have, because in weakly alkaline medium or in water, MnO4 minus permanganate ion, it changes to MnO2. Now next reaction we have MnO4 iodide, and in presence of water or in weakly alkaline, so MnO4 minus, that one changes into MnO2, and iodide, that one changes into iodate. Next we have MnO4 minus plus 4 hydrogen ion. So this one reaction, this is a reaction where the concentration of hydrogen ion that influence the reaction of permanganate ion. So here 4 moles of hydrogen ion we are having. So in that case 3 electrons, so that is changes to MnO2. And last reaction is about a decomposition of potassium permanganate. For this, if you just recall what we did during the preparation of potassium permanganate, MnO2 that changes into K2MnO4, K2MnO4 that changes into KMnO4. So you see what we do here, simply reverse the reaction. This KMnO4, it on decomposition, it gives K2MnO4, MnO2 plus oxygen.